Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss some various types of receivers, especially in amplitude modulation receivers, and the basics of how an amplitude modulation receiver is working. And I also discuss the various types of AM receivers, that is tuned radio frequency receiver and super heterodyne receiver. Now we will see radio receiver. Intercept the electromagnetic waves in the receiving antenna to produce the desired RF modulated carrier. It selects the desired signal and rejects the unwanted signal. These are the some benefits of radio receiver. Apart from this, it will amplify the RF signal. It directs the RF carrier to get back the original modulation frequency voltage, amplify the modulation frequency voltage. The main features of receivers are its simplicity of operation, good fidelity, good selectivity, average sensitivity, adaptability to different types of aerials. Imagine if a receiver has a poor selectivity. If you see this figure, the sender will send the information of "Hi bro, can you hear me?" But due to this poor selectivity, the receiver cannot hear what is the voice. This selectivity can be caused due to any cloudy seasons or rainy seasons, or sometimes there is a moving objects in between a sender to the receiver. So this will cause some bad effect in wireless communications. Next, if a receiver has poor sensitivity, that is, they have very weakest signal. For example, the sender can send a signal from Sydney to New York. If they speak "How are you?" but due to sensitivity, they can hear only HWOEY. So this is the very problem of poor sensitivity. Then poor fidelity. Poor fidelity means they can hear a different noise levels. For example, the sender can send "How are you?" message, but the receiver can receive some mistakenly and they can reply "My father is fine." So these are the major problems of a normal receiver. So in order to avoid this, we are going to use AM radio receiver. Radio receiver is an electronic equipment which picks up the desired signal and rejects the unwanted signal and demodulate the carrier signal to get back the original modulated signal. So this is look like how an AM radio receiver is looking. The main functions of radio receivers are: it selects the desired signal and rejects the unwanted signal. It amplifies the RF signal. It demodulates the selected signal. There are two types of AM radio receivers are available. One is called a tuned radio frequency receiver and another one is called the super heterodyne AM receiver. So in this YouTube video, I am going to discuss both the receivers. So if you see this block diagram of tuned radio frequency receiver, first the received signal is given to first RF amplifier, followed by second RF amplifier. Then both these output are given to detector. Then detector followed by audio amplifier for amplifications of input signal and also noise removal process. Then further, the power amplifier will increase the gain of the audio signal and it deliver the signal to speaker for telecasting. A tuned radio frequency receiver or TRF receiver is a type of radio receiver that is usually composed of one or more tuned radio frequency RF amplifier stages followed by a detector or demodulator circuit to extract the audio signal and an audio frequency amplifier. It is popular in 1920s. It could be tedious to operate because each stage must be individually tuned to the station frequency. By the mid of 1930s, it was replaced by the super heterodyne receiver invented by Edwin Armstrong. So this is the old generator using a tuned radio frequency receiver. It looks like more number of transistor and capacitor transformers are arranged in a serial and parallelic format. The classic TRF receivers of 1920s and 30s consist of following three sections: one or more tuned RF amplifier stages. This amplifies the signal of the desired station to a level sufficient to drive the detector while rejecting all other signals picked up by the antenna. The detector, which extracts the audio signal from the radio carrier signal by rectifying it optionally but almost always included one or more audio amplifier stages, which increases the power of the audio signal. The advantages of TRF receiver: they amplify defined frequency, signal to noise ratio at output is very good. They are very well suited for radio transmitters and receivers. The band of frequency over which amplification is required can be varied. The main drawbacks of these TRF receivers are, since they are used inductors and capacitor as tuning the element, the circuit looks like bulky and costly. They are not suitable to amplify audio frequency for higher gain values. If the band of the frequency is increased, design must be more complex. So in order to avoid this, we are switch on to super heterodyne receiver. A super heterodyne receiver uses signal mixing to convert the input radio signal into a steady intermediate frequency that can be worked with more easily than the original radio signal that has a different frequency depending on the broadcasting station. The IF signal is then amplified by a strip of IF amplifiers and then fed into a detector that outputs the audio signal into an audio amplifier that powers the speaker. So there are 9 stages are available. If you see this figure, the first one is the RF amplifier, the RF filter stage. Second one is the local oscillator stage, followed by mixer stage. Then first IF filter, first IF amplifier, second IF filter, second IF amplifier, third IF filter, then followed by an audio detector. Finally, in order to increase the signal quality of the audio signal, we can pass the detector output to audio amplifier. Then finally, the speaker will telecast the original signal transmitted by the transmitter side. Now we will see individually. RF filter. The first block is the ferrite rod antenna coil and a variable capacitor combo that serves two purposes. RF is induced into the coil and the parallel capacitor controls the resonant frequency of it, as ferrite antenna receives the best when the resonant frequency of the coil and the capacitor is equal to station carrier frequency. This way it acts as an input filter of the receiver. So first RF filter will remove the noise in the input signal. The second block is the heterodyne, also known as the local oscillator. The frequency of the local oscillator is set, so either the sum of the difference of the RF signal frequency and the local oscillator frequency is equal to IF used in the receiver. Mixer. The third block is the mixer. The RF signal and the local oscillator signal is fed to the mixer to produce the desired intermediate frequency. Mixers found in common AM receivers output the sum, the difference of the local oscillator and the radio frequencies and the local oscillator and RF signal themselves. Most of them in similar transistor radios. The heterodyne and the mixer are made in using one transistor. The fourth block is the first IF filter. In most AM receiver, it is a resonant circuit placed in the collector of the mixer transistor with the resonant frequency equal to the IF frequency. Its purpose is to filter off all signals with the frequency different from the IF frequency, because those signals are unwanted mixing products and it doesn't carry the audio signal of the station we want to listen to. First IF amplifier. The fifth block is the first IF amplifier. It gains of 50 to 100 in each IF stages are common. If the gain is too high, distortion can take place, and if the gain is too high, IF filters are close to each other and not properly shielded, parasitic oscillation can take place. So because of this problem, we can use the automatic gain control voltage from the demodulator. The automatic gain control lowers the gain of the stage, causing the output signal to roughly the same regardless of the input signal amplitude. The sixth block is the second IF filter, just like the first one, and it's a resonant circuit placed in the collector of the transistor. It only lets signal of the IF frequency, improving selectivity. The seventh block is the second IF amplifier. It is practically the same as first IF amplifier, except it is not controlled by automatic gain control, as having too many AGC control stages increase the distortion. The eighth block is the third IF filter. Just like the first and the second one, is a resonant circuit placed in the collector of the transistor. It only lets signal of IF frequency, improving the selectivity, and it feeds the IF signal to the detector. The ninth block is the detector, usually in the form of germanium diode or the diode connector transistor. It demodulates AM by rectifying the IF on its output. There is a strong IF ripple component that is filtered out by a resistor capacitor low pass filter. So only audio frequency components remains and it is fed to the audio amplifier. The audio signal is further filtered to provide automatic gain control frequency voltage like a regular DC power supply. The 10th block is the audio amplifier. It amplifies the audio signal and passes it onto a speaker. Between the detector and the audio amplifier, a volume control potentiometer is used. So by using this volume control potentiometer, we can adjust the volume of the speaker from the audio signal. The last block is the speaker. Usually it consists of 8 ohm 0.5 watt speaker that outputs the audio to the user. The speaker is sometimes connected to the audio amplifier through a headphone jack that disconnects the speaker when headphones are plugged in. So some features or some characteristics of Super 809 AM receivers are intermediate frequency, amplification, band pass filtering, high performance, selectivity and sensitivity. So in this YouTube video, I discussed what is meant by receivers and I discussed some of important uses of selectivity, sensitivity, fidelity. Then the uses of AM receivers are discussed. Then the two types of AM receiver, that is TRR receiver and Super 809 receivers are discussed. Thank you for watching my video.